I'd like to thank the Society for the opportunity to present on the topic of nontuberculous mycobacterium infections associated with heater-cooler devices at this special session at the STS. Prior to proceeding with the abstract, I'd like to provide you with a little bit of background and context that surrounds how this abstract came about. We're obviously all familiar with heater-cooler devices. Heater-cooler devices are used in cardiac procedures to provide temperature-controlled water to heat exchangers used during cardiopulmonary bypass. There currently are 5 commercially available heater-cooler devices for use by cardiac surgeons. Hugo Sachs out of Zurich got the ball rolling when he published a paper describing a prolonged outbreak of Mycobacteria chimera infection after open chest heart surgery. Within this paper, he described 6 patients who had invasive M. chimera infections. All of these patients had a history of cardiopulmonary bypass with implants, and ultimately M. chimera was detected not only in the heater-cooler water circuits, but also in air samples collected while units were operating. The FDA in October of 2015 issued a safety alert that noted that the FDA had received numerous reports of atypical infections in patients exposed to contaminated heater-cooler devices. Genomic testing had identified NTM as the primary organism, and contaminated water within the heater-cooler device was the implicated source. The safety communication applied to all heater-cooler devices, and their recommendations included adhering to manufacturers' instructions for cleaning and disinfection and maintenance, using only sterile or filtered water, which was not a common practice prior to 2015, directing the heater-cooler device exhaust away from the surgical field and keeping the device as far away from the surgical field as possible, and any units that had signs of contamination should be removed. What is nontuberculous mycobacterium? It's a slow-growing mycobacteria that does not cause tuberculosis. There's over 170 reported species. NTM is often referred to or known as Mycobacterium avium complex, or MAC. It includes M. chimera, avium, abscessus, intracellulari, and these 4 bacteria represent about 40% of all NTM isolates. It is absolutely ubiquitous in the environment: surface water, tap water, soil. It's particularly endemic in premise plumbing, houses, apartment buildings, hospitals. If you took a shower in your hotel before you came to this meeting this morning and you looked up at the shower head, took a big breath and a big gulp of water, you likely took in a lot of NTM. Historically, NTM has had a clinical presentation primarily confined to pulmonary, with the route of transmission being inhalational. It typically is a low virulence organism. It's very opportunistic, commonly occurred in immunocompromised patients or patients who had breaches in their normal host defenses, COPD, sarcoidosis, bronchiectasis. NTM infections, however, that are associated with heater-cooler devices represent a very different epidemiological phenomenon. Despite CDC and FDA alerts that continued to come out of both of these organizations, physician awareness of heater-cooler infection risk appeared to remain low and needed to be escalated across the clinical community. In 2016, June of this last year, the FDA convened a special session of their circulatory system device panel. The purpose of this was to bring together experts from around the United States and the world to help the FDA understand and make recommendations for mitigating NTM infections related to heater-cooler device contamination. It's the data that was generated by the FDA that was used during that meeting and the conclusions that were drawn from that meeting that represent the abstract that I submitted to the STS and I'm going to present to you here shortly. I want to call out 3 clinical colleagues that were on that panel, both from pediatric and adult cardiothoracic surgery as well as cardiology. I want to particularly call out and point out my FDA colleagues that I've gotten to know and have worked with through the years that helped me pull together this data in a presentable form at this meeting. From 2010 to August of 2016, the medical device report database was queried for adverse events reported as either patient infections or device contaminations associated with heater cooler devices. You need to understand that the MDR database houses hundreds of thousands of reports that the FDA gets every year that are submitted by both mandatory reporters, such as manufacturers, importers, or user facilities, i.e. hospitals, or voluntary reporters, patients, healthcare providers, consumers. It's also very important that we understand that the MDR database is a simple passive surveillance system. From this database, you can't calculate mortality rates or event rates, or even how interventions might be changing those event rates. Between January of 2010 and August of 2016, the FDA received 339 MDRs detailing heater-cooler device contamination or patient infections. They came from manufacturers, user facilities, and one patient. I want to applaud Dr. Prager and Dr. Bavaria for prodding me to collect the most recent data available. And when we submitted our abstract, it was truncated in February of last year. From February to office, through tireless work by the FDA, we have accumulated an additional 159 MDRs that will be included in this presentation. So the numbers are different from what's been published in the abstract book. Reports originated both outside the U.S. as well as within the U.S., and it needs to be noted that reports involved all 5 heater-cooler device manufacturers. However, 89% of the MDRs involve the Sorin 3T device. MDRs included 107 reports of infections involving at least 86 patients. As you can see here, patient infections were associated with 4 of the 5 commercially available devices. MDRs also included 232 reports of heater-cooler device contamination without comments about associated patient infections. As you can see here, contamination of heater-cooler devices has been reported from all manufacturers. And finally, among the reports of infection in at least 86 patients, unfortunately, death was reported in 15 of these patients. These are the 3 manufacturers that had deaths reported that were associated with their contaminated devices. During this time period, the surgical procedure involving the heater-cooler device was identifiable in 94 of the MDRs. As you can see here, 50% of the procedures involved device implants such as LVADs, valves, rings, and/or vascular grafts. The location of the infection was identified able to be identified in 83 of the MDRs. It's important to note that a critical feature of this particular infection is the long latency period from exposure to diagnosis. The time from the surgical procedure with the heater-cooler device to diagnosis was quantifiable in 67 of the MDRs and was reported up to 60 months following the initial surgery. NTM was the most frequent organism in the MDRs, with M. chimera being the predominant isolate. NTM, however, presents incredibly unique laboratory challenges, not only for accurate culturing, but also for speciation and identification. NTM are characterized by their growth rate. You divide them into slow and rapid growers. Slow growers like avium and chimera take at least 7 days to begin to form colonies, while rapid growers, if you call it rapid, take somewhere between 5 and 7 days, but usually less than 7 days to begin to form colonies. These would be bugs like abscessus. Proper identification and speciation, however, requires specialized labs and personnel and can take up to 7 to 8 weeks for this to be completed. Critical to this is that physicians need to make the laboratory aware that NTM is a potential organization. If you don't know to look for it, you will never find it. Finally, when you look at the MDRs, it was interesting to note that a lot of the organisms were simply grouped as MAC or Mycobacterium avium complex, or they were identified simply as unspecified Mycobacterium or just simply as NTM. And I think this lack of speciation and specification of what the bug was is a real problem with NTM. And it's reflected in what we saw in the MDR report. So how does NTM get into the heater cooler device? Obviously, it can occur at the production line, or it can be on us. And although prior to 2015, when most people started using sterile or filtered water, where the water came from that went into these devices is anybody's guess. It's clear that there was a production line source of contamination with the Sorin device. M. chimera was found in the production line at Sorin manufacturing plant and linked by whole genome sequencing to patient infections in Europe. Genome testing is currently underway to determine if the same organism is linked to multiple U.S. outbreaks. When we look at the etiology of heater-cooler device contamination, it's not just one manufacturer, but there appears to be a device class effect that makes all heater-cooler devices susceptible to both contamination and aerosolization of NTM. Prior to 2015, as I noted, most programs were not using sterile or filtered water. Once a device becomes contaminated, NTM are prolific biofilm formers. Once organized into biofilms, even routine cleaning is ineffective at achieving decontamination. And finally, tank and circuit materials can hinder regular cleaning that favors biofilm formation. When I came back from the FDA meeting, I took the panels off our 8 devices, and 2 of our devices looked like this. They were obviously taken out of service. The heater-cooler device design can encourage transmission of aerosolized NTM into the sterile field and override operating room laminar flow designs. Laminar flow designs are not necessarily protective. This was clearly outlined in a very nice paper by Summerstein, and you'll see in the video, you've got a heater-cooler device with the exhaust facing the surgical field. This is a functioning operating room. Laminar flow is going. And within 10 to 12 seconds, you begin to see in the right field the smoke that represents potentially aerosolized NTM wafting and swirling over the operating room table, clearly not impacted by the laminar flow. The exhaust fans and internal fans in these devices, while they vary in strength, have a clear impact on negating the benefit of laminar flow designs. The FDA and the CDC have some guidelines, recommendations for all heater-cooler devices. We need to adhere to maintenance schedules for manufacturers' device labeling, use only sterile or filtered water, direct the heater-cooler exhaust vent away from the surgical field and place the device as far away as we can, and remove from service any heater-cooler devices that demonstrate biofilm formation. One of the things that's not recommended is to test heater-cooler devices to identify units that are potentially contaminated. There are some specific recommendations for users of the 3T device from Sorin. 3T devices manufactured before September of 2014 should be transitioned out of service until the manufacturer has implemented strategies to mitigate the risk of device contamination and patient infection. It's my understanding that Sorin is currently working with the FDA on a strategy like this. Patients also exposed to 3D devices since January 1st of 2012 should be notified in writing of the potential risk of NTM infection. In conclusion, NTM infections associated with heater-cooler devices have a long latency period and are frequently and unfortunately lethal. The incidence is likely underreported due to difficulty in culturing and lack of awareness by managing physicians. And finally, cardiology and cardiothoracic surgery awareness is critical to implementing short and long-term solutions to this emerging public health concern. Thank you very much.